Hi, I'm Chelsea Karakozova. I'm a product manager for STEM math products at Pearson, and I'm based in Boston.
Hi, I'm Mike from Silva, a Zurich-based edtech startup using Wolfram technologies. In our presentation, we show how Silva helps Pearson to create interactive math exercises.
I work at Pearson as a product manager on our MyLab Math platform, which currently serves millions of students in the US and worldwide. MyLab Math is a fully featured content and assessment platform. Students come here to read the e-text, do practice homework, and even take high-stakes assessment. Where we do see a bit of a gap is in our assessment questions. We have a bank for each title of thousands of questions that consist of multiple choice, free response, drag and drop, interactive, video. But we have a consistent request from faculty to drive conceptual understanding and to really promote engagement with students, to get away from rote memorization that they're likely to forget next week. And that's why I've decided to pilot some Silva-powered exercises in our products this fall, and I'd like to show you a little bit more about why. So what you're seeing on screen is from the Calculus e-text, completely composed in Mathematica by Briggs, Cochrane, Gillette, and Schultz. And this is a replacement for the traditional paper book. And students come here to learn the concepts, and then they would go to MyLab Math to work on homework assessment. So here is chapter 3 on derivatives. So as they're reading the narrative text interspersed with practice, there are hundreds of these interactive figures woven throughout the narrative. And for this example, we have a graph of the derivative. And we've got some really lovely tangent lines illustrating the concept to students. And as I say, there are hundreds of these baked throughout the narrative text. And if you see, it suggests related exercises 17 to 18. So if we hop over to the MyLab, we see what that question looks like rendered in the MyLab currently. We have a static image and a multiple choice selection for students. This is just not nearly as interactive as the experience they were just having in the e-text and doesn't encourage conceptual, deep understanding of the concept. So let's take a look at what this question could look like using Silva. Here we have the same concept illustrated, only now students are interactively asked to graph f prime by moving these locator points. These types of questions, compared to what we just saw in the MyLab with the multiple choice, really drive home the concept of the tangent line and slope to students more than a multiple choice question ever could. Let's look at another example. Here we are back in the Mathematica e-text, and this time we're in chapter 5, learning about area functions. So once again, students are presented with narrative and the opportunity to see the concepts in action using these interactive figures, to essentially learn by doing. Back in the MyLab, this is an example, a representative example of the types of exercises that would be available for this concept. So we have a static figure where students are asked to find and graph the area function, which they would need to do on their own piece of paper, and enter a free response here, followed by a multiple choice piece where they're matching. Now let's take a look at what this looks like as a Silva exercise. Here students are given the chance to interact and create the graph by moving these locator points once again. They're able to see an immediate impact of their actions on the graph. They're invited to play around with it and are all in all more engaged and hopefully obtaining some of that elusive conceptual understanding that is a consistent request from instructors. You'll notice that this is placed into a Pearson UI, so this exercise would sit along others in a student's homework. They're able to check their answer receive immediate feedback, and once they're satisfied with their answer, they would save and submit. This would be scored alongside all of those hundreds and thousands of exercises that we currently have in the MyLab. So you would, as an instructor, you would be able to create an assignment that did have some skill and drill exercises, perhaps a video assignment mixed in with some of these interactive style questions, some skill maintenance style questions. So you could devise an assignment that was more than just drilling the skills from a particular section. You would give students the opportunity to watch a little, do a little, learn a little.
Thanks, Chelsea. We are really excited to collaborate with Pearson to make math exercises more engaging. It's great to see what the Pearson authors already achieved with Silver, and today I want to show you a few more insights on how it works, how we set up questions and grading. Let me start by highlighting 4 main features Silver offers to authors. Number 1 is interactivity. Let's look at the example we've seen earlier. Here the authors took full advantage of all the powerful features Mathematica offers, such as creating dynamic interfaces in combination with graphs. And with that, they created a truly interactive experience for the students. As they moved the locators, the slope of the black lines would immediately adjust. This is interactivity. Now, imagine a student would like to exercise a little more. Then it would be really boring if they would always get the exact same question. And for that, we offer parametrization and randomization. That is creating different but similar versions of one and the same question. Here the task is the same, but the numbers change, the graph is mirrored, and so on. This is parametrization and randomization. Number 3 is the autograding. Let's try to solve this question. As I move the locator, I see here now the black line is tangent. And as we know, the derivative of a quadratic function is a linear function. So let me try to get this right. All right, let's check our answer. And it's correct. We get an additional explanation. You found the derivative function. For quadratic function, the derivative is always a linear function. Now, this is autograding. What is really important for the learning experience are the cases where the student doesn't get it right. So imagine they would forget to move the first locator. Let's try this. Now they get a feedback that it's incorrect, but with a tailored explanation. The first point is not correct yet. Make sure the black line is tangent to the blue curve and that you get a straight red line. Now, let's do this. And now we see third case, it's graded as partially correct. So it's almost right, but outside of the error tolerance we defined. And of course, that can be fully customized. That's number 4, tailored feedback. And now you may wonder, how do we create such questions? At Silver, we want to equip all educators with some mathematical knowledge with a tool that they can create such questions. And for this purpose, we created Creo. Creo is Silva's authoring tool. It's an add-on to Mathematica, and once you install it, it will be available through the palettes menu. It takes care of all notebooks and files and questions and so on, so that you don't need to worry about it. Now let's look at the notebook that created the question we've seen earlier. Number one is graph and area function. Here you can see that once the dynamic content gets a little more deep, the code also will get a little longer. Here is the second example we have seen, a little bit shorter. And here you also see the grading. But let's start with something easy, something from scratch. When you create a new question, it will just look like this. So assume you started with prototyping in the Mathematica notebook. Here we have a dynamic module that includes a simple locator pane, some disks, and now we want to turn this into a question. How can we do that? We simply copy and paste the code into Creo. We want that it's an interactive question, so copy and paste. That's it. Now, what kind of question could we ask about it? We could say something like, find the green disk. Okay, and now we need to look at the grading. Here we defined a point, and this is dynamic, so this will be our locator later. So what we can do is just say the point needs to be smaller than 0.5. And since we are interested in the x-coordinate, go the first on that. All right, now let's preview this. So here we go. We have a question, find the green disk, and we can move the locator and point it here to the green disk, and we will get a correct. Now, if we do this again, we get the exact same question, and if we don't get it right, it will simply be incorrect. Okay, now let's try to inject the parametrization here. In this case, it will be easy to just use different colors. So let me replace the green with color and add a parameter. We call this parameter color and make it a custom list of colors, red, blue, green, and so on. Now we want to inject this into our interactive interface. So we replace the green by template slot and then simply color. Now, in order that those colors get recognized, we add a capitalize and true expression in front. All right, let's test this now. We see that we get immediately a different version. So now it picked pink one and created the nice color disk. So let's try another version. and we get the blue one. So we injected the parametrization and randomization, but we still have only kind of black-white grading. Either you get it right or you get it wrong. So let's add a few more conditions here. All right. Now we can test our question again. We get a different version, and let's see what we get when we get somewhere in the middle. Now this is considered partially correct, and the grading works like this. If you get the red one, you get full points, and for each disk you're away, you get 1 point deduction. Okay. Now we've set up a question with parametrization, with partial grading, but let's look at the feedback now. We have two fields. One is the solution, one is the explanation field. The solution is given when you either did not get it right after a couple of attempts, or when you get it right at some attempt. In this case, we could just type something like, well done, but that would be a very static message. So instead we can toggle here and use an expression. So we could say this is, and then pick the right color, disk, and we could even show it. All right, let's test this. Now if we move here, get it correct, and this is the right disk. Okay. Let's look at the explanation now. Remember, this is for the case when the student doesn't get it right. So what we could do here is just saying something like, you did not find the right disk, but we can go even further. So here we can say, you haven't found the right disk yet, and then we can give tailored feedback by taking into account the answer they provided. So in this case, we can extract from the given answer the point, and as we know, this is a coordinate. We take the x value again, rounded, and this gives us the number of disks they have away from the actual solution. Let's try this. Okay, so I move it here in the middle, and this would be 3 disks away. And we get, you haven't found the blue disk yet, move the locator 3 disks further to the left. And this is how we can provide tailored feedback based on the answer the student provided. And now you have seen all the main features in a very simplified way. So let me recap. We were able to create different versions of a question by inserting a parameter. We randomized the color based on a list we provided. We set up partial grading so that each step or each state could be distinguished. And we provided individualized and tailored feedback based on the question, based on the answer the student gave. Once the authoring process is completed, we can simply give a name to our question and ask Creo to deploy, which is as easy as one click. And now what we get is a MyLab ready question. There's so many more things we can do with Creo, but let me hand over to Chelsea again to share some feedbacks from the authors with you.
Pearson authors are really excited by the possibilities. Eric Schultz, the co-author of the calculus e-text we viewed earlier, emailed me late one evening to say that he had written the Mathematica code which recognizes multiple parametrization forms for tangent lines to curves, with free-form input to boot, multiple exclamation points. Our current MyLab exercises will typically ask for the standard parametrization for the tangent line, so this represented a breakthrough for him on that particular question. A few days later, another note from Eric came in. Exercises in the textbook will often ask questions that we cannot exactly replicate in the MyLab. So consider an exercise that asks the student to sketch the graph of a function satisfying some properties like increasing, decreasing, increasing at a decreasing rate, etc. on this interval or that interval. I like to call these the answers may vary exercises, since that's what you would see in a solutions manual. So Eric has coded several new exercises in Creo that allow students to draw these functions that satisfy a set of properties and have their answers graded by Silva. So more exclamation points. These are exactly the kinds of exercises that instructors and author/instructors would like to assign to students, but doing so on paper is not scalable, and doing so in the MyLab is not currently possible. So with these new tools, it is, and instructors will have yet another exercise type that they can assign to students that drives that conceptual understanding. Another challenge we face in the MyLab is interpreting student responses. So students use palettes in the MyLab to enter expressions in a particular way, and the system scores them very rigidly on what they entered. So by using Creo, it allows us to leverage the linguistic knowledge of Wolfram Alpha to interpret student input to exercises. So consider a randomly generated exercise where the answer is sine x, parentheses x. The following inputs in Silva would be accepted as correct. Of course, sine parentheses x, sine with a capital S, parentheses x, sine square brackets x, sine space x, sine x no parentheses. So Eric did this using a Mathematica command to interpret the student answer into a precise expression, and then compared it with the correct answer that has been computed into the code. So expressions randomly generated, correct answers computed by Mathematica, student input parsed using Wolfram linguistic knowledge, and interpreted student answer compared to the correct answer, and at last credit given in the MyLab. This is a seemingly small piece of the puzzle, but this represents a real improvement for students who can sometimes feel defeated by the tool when they've truly understood the underlying concept. It can be discouraging to be marked incorrect for a small error like that. So bringing this, the linguistic knowledge to bear on these exercise types will be felt immediately by students and instructors. So I've really focused on calculus, but a pilot is also underway at Pearson for pre-calculus, for linear algebra, and differential equations. and the authors of those titles are equally enthusiastic about Silva's potential, as it will help them bring their first-rate content from their books to life for students within the MyLab.